So section 6.4 actually reviews a concept that we did all the way back at the beginning of the year when we started simplifying square roots and radicals. So in the prerequisite unit, we did look at how to simplify a radical expression. So we're essentially reviewing that particular concept. So we just came off of a section not too long ago when we were doing inverse functions. A power and a root are inverse functions. So the most basic one, if you have something raised to the second power and you take the square root of it, those two are opposites of each other. Those are inverses. So the same thing applies with x to the third and the cube root of a number. X to the fourth root, x to the fifth root, so on down the list. The exponents should be bigger and bigger and bigger. The roots can be bigger and bigger and bigger. So that gives us the concept of an nth root. So an nth root, the standard notation for it is n raised to some value a. So a is the radicand, that's the expression you're taking the root of. N is the index, what kind of root you're taking. So if there is no index, a couple of key points to keep in mind. If there is no index, it is understood to be 2, making it a square root. If the index is even, then it's plus or minus. Make sure you put plus or minus in the answer. For your numbers, you simplify them. If they're an expression, then you divide the exponents, which we'll review in a second. And complex numbers, imaginary numbers, the i's still apply. So i's still will show up. They are still valid in terms of getting those as answers. So with that, let's start with a few examples. So again, there's examples 1, 2, 3, 4. That way, those people who are going to work ahead can work ahead. So example 1, let's start off with something pretty basic. The square root of 25 y to the second power. So the square root is over both parts. So that means you're doing the square root of 25 and the square root of y squared. So you're doing the square root of both. Square root of 25 is easy enough. That's 5. For y squared, so when you're dealing with variables or expressions, that's when you are dividing the exponents. This is a situation when you're dividing the exponents. So there's an understood 2 sitting on the outside. So this part is y to the 2 divided by 2 power. 2 divided by 2 is 1. So you get 5y. So your final answer would be plus or minus 5y. Plus or minus comes into play because this was an even index. The even index because the number up there would have been 2. Questions, example 1. Yep, if there's no number there, it is understood to be a 2. There's no number for the index, it is understood to be a square root. So, excellent question. Any other questions before we move on? All right, example 2. So example 2, you have the opposite of the square root of t squared plus 8 raised to the 12th power. Now, please do not write t squared plus 8 12 times and multiply it out. Number 1, you don't have time to do all that. Number 2, I don't have time to look at it. Leave it as t squared plus 8 raised to the 12th power. We can simplify it using our powers. There's no number out there, so it's understood to be a 2. So we're going to take t squared plus 8 raised to the 12 divided by 2 power. So 12 divided by 2 gives you 6. The minus sign that was sitting in front just comes down. And that's your final answer. That's it for that problem. So the key thing to keep in mind here, plus or minus is not necessary because of that minus sign out in front. So again, problems are going to be different. So you have to take a moment, look at the problem before you start solving it out. Again, you have time to do it right, or you're going to make time to do it over. Those are your 2 options. Questions 1 or 2? All right, let's take a look at example 3. So example 3, we have the 5th root of 1,024, p to the 10th, and q to the 35th power. So 5th root, 1024, p to the 10th, q to the 35th power. So notice that we have 3 items underneath, so we can separate it if we choose to. 5th root of 1024, 5th root p to the 10th, 5th root q to the 35th power. You don't want to separate it, don't separate it. So now we do each part. So 5th root of 1024 means what to the 5th power is 1024. So we let our calculator do a little work. So here's my graphing calculator. So I'll take you through how to input this in the calculator. So since it's a 5th root, you're going to press the number 5 first because you want the 5th root. Then you're going to go to math. The 5th option down is what you would use for roots that are bigger than 3. The calculator already has a square root key. The calculator already has a cube root key. For anything higher than the number 3, you use the 5th button down. And then you type in the number that you want. So the 5th root of 1024 is 4. Now, for those of you who are just going to do the guess and check method for it, please understand these will include decimals. We're actually going to do a decimal example later on. So the guess and check method is not going to work all the time. So you're being warned in advance, you're going to need to know how to use the calculator to solve it. So if your calculator wasn't out at this particular point in time, we will do another calculator example later. So that means you probably need to get your calculator out and be with us at that point. For the variables, we do the exact same thing that we've been doing. That's P 10 divided by 5 and Q 35 divided by 5. So your answer is 4 P squared Q to the 7. Questions, example 3. We don't need to because the 5 is an odd number. So odd index, no plus or minus. So very good catch there. So if you have an odd index, you do not need the plus or minus. Any other questions, example 3? All right, example 4. Example 4, the square root of negative 49 m to the 4th and squared. Again, if there's no number sitting there, it is understood to be a 2. So this would be the square root of negative 49, the square root of m to the 4th, and the square root of n to the 12th. So this particular example is simply to remind you that if you take the square root of the negative number, i's are still in effect. So you still get I as part of your answer. Square root of 49, negative 49 is 7I. M to the 4th, so that's M 4 divided by 2, N 12 divided by 2. So your final answer, plus or minus 7I, M squared, N to the 6th. Question example 4. So each of the first 4 examples had a little bit of a wrinkle to it, depending on the problem. Of course, if you missed any part, you're more than welcome to catch it once I upload the notes later on today. So we'll do those on the screen as we look at. So examples 5 and 6 are special case scenarios. So in this scenario, for radical problems in which you are dividing an even exponent, even index, and you get an odd result. Even exponent, even index, and you get an odd exponent. So for example, and I'll put it in green over here, you have and I'm trying my best to make it up off the top of my head, the 6th root of 64 n to the 18th power. The 6th root of 64 n to the 18th power. So in this case, we're not necessarily worried about the number. The 6th root of 64, we can take care of that easily. That's 2. So n to the 18th, well, that's 18 divided by 6. That's 3. 3 is an odd number. So if the answer part ends up odd, then you're going to take that expression and put it inside of an absolute value. So if the answer that you get is odd, then you put it in the absolute value. Why does that matter? Because you want your answer to produce a non-negative result. In other words, a positive result. To ensure that we take the absolute value. So it's not something that's out of this world hard. It's just something you have to pay attention to. So 18 was an even number, 6 is an even number, but the answer you got was odd. That's the only scenario in which you have to pay attention to it. And we're going to do a couple examples so that you're familiar with it. But any questions before we work examples 5 and 6? All right, so let's do 5 and 6. So example 5, you have 36 y to the 6th power. So there is no index sitting there, so it's understood to be 2. So you have the square root of 36, and you have the square root of y to the 6th. Square root of 36, that's 6. That takes care of itself. Since there's an understood 2 sitting up there, 6 divided by 2 is 3. 3 is an odd number. So you put y to the 3rd inside the absolute value. And then the only thing that's missing there is the plus or minus 4 to 6. Questions, example 5. All right, not seeing any, not hearing any, so we must be okay, so let's move on. Example 6, same type of problem. 4th root, 625, b plus 3 raised to the 12th power. So again, go ahead and separate everything. Fourth root, 625. Another opportunity to use the calculator. Type in the number 4. Go to math. Go to the fifth button down. Type in 625. So we get 5. So for the second part, we have b plus 3 raised to the 12 divided by 4 power. B plus 3 raised to the third power. The 3 is an odd number, so the expression goes in the absolute value bars. And lastly, it was odd. I mean, it was even outside, so the 5 means plus or minus. So for some of you, just notice that for these problems, there's a lot of detail oriented, there's a lot of precision that has to go into the problem. If you're thinking of being a doctor, anything medical, engineering, you're gonna have to deal with a lot of precision. You get paid a lot of money to be precise. You get paid a lot of money to be precise. So just pay attention to what you're doing. Any questions, 5 or 6? All right, and we'll finish off our work today putting our calculator to use. So all of our numbers so far have been nice and neat, no decimals. Yeah, that ends now, because it's not realistic that everything is going to come out nice and neat. So example 7, fifth root of negative 37. So we're going to let the calculator do its work. So when we are using our calculator, primary rule of thumb will be to round to 3 decimal places. So that's the rule of thumb that we're going to follow unless your problem specifically tells you to do something otherwise. So we're going to follow the rule of 3 decimal places. So let's go to our calculator. So the problem was the fifth root of negative 37. Type in the 5. Go to math. Go to the fifth button down. Type in negative 37. So you get negative 2.0589244136. We're rounding to 3 decimal places. It's negative 2.058. You have a 9 sitting behind it. So that's going to change to 8 to a 9. So negative 2.059. Note there using calc. Using calculator. So again, it's incumbent upon you to still have a calculator. If you're in an honors algebra 2 trig class, you should be using a graphing calculator. Math and calculator is pretty much the rule of thumb from here on out in your mathematical life. All right, so problem 8. The surface area of a sphere can be determined from the volume of the sphere using the formula S equals the cube root of 36 pi v squared. V is the volume. Determine the surface area of a sphere with a volume of 200 cubic inches. So nothing fancy about this particular problem. We're going to take 200, we're going to plug in for V. So 36 pi V squared. So that's going to become the cube root 36 pi times 200 squared. And we're going to let the calculator do that work. So what we're typing in is cube root 36 pi times 200 squared. So there is a cube root function in the calculator. So if you go to math, the fourth button down represents cube roots. So that's already in the calculator. So if you wanted to type 3 and press the number 5 key, the same thing will happen. So don't get stressed out with that. 36, the pi button is located where the exponent key is. So that's second exponent key. Open the parentheses, 200 squared. So I literally just threw everything into the calculator. Literally just put everything in the calculator. So 165.388. There's a 0 behind it, so that doesn't do anything. 165.388. And that is square inches because you're dealing with area. Square inches, you're dealing with area. Any questions? Example 8. Again, if you need help operating your calculator, feel free to come see me during asynchronous time. I'll help you as much as you feel like you need it. If your calculator wasn't out, then that's a you problem. You should have your calculator out. You are in the math class. Example 9. If the surface area of a sphere is about 214.5 square inches, determine the volume. So now we have the formula, cube root 36 pi v squared. So now we're being told what S is equal to. So this is a little bit of solving an equation. So to solve this out, first thing you need to do is to get rid of the cube. Cube root, to get rid of it, you raise both sides to the third power. Raise both sides to the third power. A cube and a cube root will drop out. Let the calculator do a little bit of work. 214.5 raised to the third power is going to give you 986.9198.625 equals 36 pi v squared. Divided by 36 pi. So you get 861,250.0527 equals v squared. And then you would take the square root. So you end up with 928.034 for your volume, and that's cubic inches. So you essentially solve the equation. But nonetheless, I'll stop that.